Oh, my computer was not responding, so I had to restart the computer. Anyway, so for SQL, we're gonna go a little more. So if we search something, there are a lot of material here, and I'm going to use for this one. A note on the language, there are several languages supported, the ArcGIS Pro as well. So for SQL, and they changed it. So this is the old version. And of course, we did use Python and many times. So the interface now already changed, and you already see that. The SQL, as anytime we're filtering the data, we can do select by attribute and definition query, label classes, etc., that we use the definition query. And the query builder is not like an expression anymore, but here we want to talk about it's a robust language used by query many databases. And the tutorial that I showed was the Vankit, and I can show right here. So I took a lot of notes that will show a lot of SQL, a lot of useful thing and syntax that you can learn from the Vankit tutorial. I learning so it's a long video tutorial, but you do learn a lot of things. But for GIS, you don't need to learn a lot to as long as you know the basics to run the definition query and everything, it should be fine. So I still have like 2/3 to go, and so it's gonna be a long study, but I'm gonna do it. And I wanted to do like 5 a day, but now I'm kind of a little slow. But anyway, after I'm done with the ArcGIS Pro and more stuff, and then I will back on SQL. So the SQL is a robust language used to query many databases, and we can use many SQL operators and functions, even there is not a button, and exposes that functionality in the query builder dialogues. So the SQL operator and string functions and mathematics functions, and the wildcards and null values, and then operators, that there are also some special operators, which is really nice that if you went through the Vankit tutorial for SQL, then you will understand here better. And for example, we can reduce query size by eliminating repetitive or statement. You can or you can just say something in something. And then the list must be comma separated, and the word in is not case sensitive, because SQL sometimes it could be, but that's for some of the table name and stuff that could be case sensitive, and also works for numeric list and values in something, and instead of this, and we can say between water depth between 100 and 50 reduces the query size by eliminating repetitive and statement. But I don't know how it will work in ArcGIS Pro. So a query within another query used within geodatabase and provide ability to query from other layers and table. And table must be in same geodatabase as the data for it to work. And there was also a way to join the table. So here is suppose someone gives you an Excel spreadsheet of 10 wells in the Gulf of Mexico, and you want to quickly highlight those 10 wells. How would you do it? And load the table into geodatabase. In the same geodatabase, at the feature class, run a subselect in something in here. Or suppose you have a feature class with well data from Texas and another feature class with well data from Arkansas. Now, suppose you would like to find all of the Arkansas gas wells that have a total production greater than the biggest gas producer in Texas. How would you do it? So we load the Texas well feature class into the same geodatabase at the Arkansas well feature class. We run a query on the Arkansas well feature class using a subquery and a SQL function, and then using the functions in SQL. that we have thing on the left of the operator withers down to a value, thing on the right of the operator withers down to a value. The two values are compared by the operator. So, and we can also use the upper string and lower string, which the field calculator that we could use. Those are all in the SQL functions. How would you find out if there are any records in your attribute table for which the state name value is not all uppercases? So name, uppercase name, some other value, you can do like this. And substring we did previously, and substring we can say ref null 32 equals 20 returns value from within a string. And suppose you have an attribute table with a census block groups where two characters indicate the state, and the we did that previously, and we concatenated together, and we want to select all of the records in county 157, and the substring we did was it was like function is it's like this, and then you can do character length. You can do the length, character length string. So returns the length of a string. And suppose you are trying to check all of the parcel ID codes are exactly 15 digits long, what would you query? So then you say character length. Suppose you are trying to find any value where the row name full value is shorter than the row name value, and then you just say smaller. And function can be nested. An innermost function gets interpreted first in uppercase, and then you say substring and something. And mod, this one I never learned yet. In the MOD function, numeric exponents divisor returns the reminder after a division. The above expression will find all east-west running intersects, and east-west interstates have even numbers, and then and if the interstate number is evenly divisible by 2, the remainder is 0. This equation evaluates to true and the interstate record is selected. And how would you make an index contour stand out? Use definition query and the function. So for example, there are steps. We can copy the contour layer, and copy layer build a definition query that selects only the index contour, and change the symbol the index contour layer so that the line is thicker and darker. So field calculator tips for data query and calculation and analysis. So there are several languages support this, SQL, Python. So right now we do use Python, but for in the structure query, I think we still, it's kind of combined. And VB, I learned VB a long time ago, but I'm not that familiar. There are different syntax, and if you go to ArcGIS online, the help file that it will show you, but right now we did use it with Python. And left and right string and mid string and Python equivalent slicing, that a lot of and replace string, it was in the SQL tutorial. Anyway, it's a lot to learn, so we will show the SQL tutorial. It's a lot to learn, but we could learn and then like replacing and stuff and combine back to our ArcGIS Pro, but the interface changes a lot. So, and now we're going to create a data range selection query. So the query for event locations such as crimes almost always use data range criteria. A selection by attributes identifies the subset of features in a map layer that meet the query criteria and gets the selection color both in the table and on the map. Once you select the features, we can you can do additional processing of selected outputs. For example, we could export the selected features to a new feature class. So on the Map tab in the selection group, we're going to select by attributes. So just by the way, I'm going to do extend view, and the map of Pittsburgh has crime offenses, which has all crime offenses for June through August 2015 streets and neighborhoods. Note that the crime data of the reel has been modified to protect privacy, including changing the year of crimes. Also note that Pittsburgh is a relatively low crime city, and that crime data plotted in any city would likely look similar to the crime data you will plot in here. So now in the geoprocessing pane, we're going to, for the select by attribute. Okay, and now here we will do is in the geoprocessing pane for the layer name, we're going to select crime offenses and add a clause, new selection, add a clause. So that to make the following. Ensure that we click the cell for the date and then select the date from the drop-down menu. So date occur and is on or after, and then we will select the date. It will be July 1st, 2015 after midnight, and click add, and click add a clause again. So let's double check. So it's valid. And then we're gonna add another clause. So the verify button ensures that there are no syntax errors, but does not check for logic errors. So, and then we add clause and make the following selection as shown. And then we will do end. Time occur is on or before July 31st. July 31st, 2015, and midnight, and click add. And the same way we're going to add and the verify button and click run and leave the geoprocessing pane open. All crime offenses remain on the map, but the points for July 2015 are now displayed in the selection color. Next, we will save the query so that it can be reused. Alright, so this is weird. And I'm gonna do is zoom to layer. There, so now we can see. In the geoprocessing pane, we're going to save extension button. So right here. Okay, now okay, and then save this into the chapter 4 tutorial. Chapter 4, which is right here, tutorials, and name it will be expression. We will say query date range. Okay, and we will load this query for definition query, and query prefix is standard. Is a standard prefix for database query to denote them as queries. The QRY is the prefix, as a standard prefix for database queries to denote them as query. And then we're going to save and open the crime offenses attribute table, and then click show selected records button. So right click and open attribute table, and then select show attribute table. It's right here. Then notice that 3,924 out of 11,500 features are selected. And now we're going to close this geoprocessing pane and clear selection. What did we did? Now we're going to reuse a saved query to create a definition query. So now we're going to close it out and right click on crime offenses and go to properties and definition query, and instead of definition query, we're going to load our query expression and double click this, and this query loads and perfect, and click OK. Open the offenses and table, and let's see again. Open attribute table and then check it out. Oh, 0 selected. What did I did? So let's go to property again. Analyze and click OK.